Hello everybody. Today we're going to discuss about stoichiometry of equations with chemical formulas and calculations as well. I'm going to write down the terminology what stoichiometry means. Stoichiometry, the name looks like a little bit cozy name, but it's like stoichion means it's a Greek word. It's made from stoichion, which is an element. Stoichion is an element. Yeah, and metron is like measurement. So the word stoichiometry means measuring of elements, in other words. So this is a chapter that we're going to discuss. So the basic idea of stoichiometry is based on the law of conservation of mass. As you remember, the law of conservation of mass was discussed in chapter 2. It is one of the law of Dalton atomic theory. The law of conservation of mass states that in simple definition is mass of the reactants equals to mass of the product. So when you have mass of the product, okay, that's what the law of conservation of mass tells you. So you may have a lot of chemical reactions, and there is a new chemicals and new compositions will be formed, but at the end of the day, whatever mass of the reactant you have, you need to have the same amount of product. So mass of the reactant equals to mass of the product. That's what the law of conservation of mass states. So I may have to start with a very simple example. Let's say if you have hydrogen is a gas, react with oxygen is also another gas. It forms, if they combine in a right proportion, you get H2O, which is a water. This is a chemical change. Now, in this case, when you see the reaction, a new substance is formed. This is a chemical change because hydrogen is a gas, oxygen is a gas, water is a liquid, and new composition is formed. But in terms of the law of conservation of mass, this equation needs to be balanced. When it comes with hydrogen, the amount of hydrogen is the same here on the product side. This is the reactant section, okay, and this is the product section. So on the reactant section you have 2 hydrogen and 2 oxygen, but on the product section you have 1 oxygen, so you may put 2 here. By the way, if you put any number in front of the chemical formula, we call that coefficients. That's very important to remember. There are 2 numbers that we need to remember: coefficients and subscripts. Subscripts are, this is called a subscript here. The number underneath of every atoms is called a subscript. And a coefficient is a number in front of the chemical formula. This is a coefficient here. So in this case, you have, by adding 2 on the product side, altogether you will have 4 hydrogen. So you may have to put another 2 in front of hydrogen. So that way the equation is balanced. This is what we call it the law of conservation of mass. So one of the things that we also need to know when you have chemical equations, there are certain abbreviations that are associated with chemical equations. They're going to tell us the physical state of the substance. The most common one we use, like triangle sign. If you say triangle sign in chemistry, it means heat is involved in the reaction. You may see G. G refers to the physical state of substance, which is gas. You may see AQ, which means aqueous. Aqueous means that there's a solution where water is a solvent. If water is a solvent, we call this aqueous solution. We also have L. It is a pure liquid. We without any solute, any solid substance is present, just a solvent. Just if you have a pure water, for example, if it's liquid, or if there is no any solute, we use L. We use P, for example, refers to pressure. If pressure is applied in the reaction, we use S, refers to solid. We use T, refers to temperature. We also use a sign like this. This is called a reversible reaction. Don't expect that every reaction is a forward reaction. We have a forward reaction and a reversible reaction. Maybe we can discuss in other chapter. If you have only one sign, it's a forward reaction. There's a one-way reaction. These are the symbols that we're going to use. Of course, if for example, if electrolysis is applied, you can say ELECT. So that means electrolysis. To decompose compounds, we use electrolysis. So you can use these abbreviations. These are one of the common abbreviations that we're going to use. So chemical equations, it's not just to show you reactant and product. It also needs to tell you the status of the substance, whether it is liquid, what are the status of reactants and products. At the same time, what conditions, what variables are used, pressure or temperature. If they are using, we can also use those variables. So chemical equations doesn't just provide you that equations are balanced. It should provide you the complete information. For example, if you say CH4 gas plus 2O2, and I put a heat sign here, and this is, by the way, a combustion reaction, and a combustion reaction always produces carbon dioxide and water, and you can see that this chemical equation, this is a combustion reaction, but it's not only that. There are a lot of information here. First of all, the equation is balanced. The equation is balanced. Balanced means that the total number of atoms on the reactant side and on the product side are the same. You have 4 hydrogen here, you have 4 hydrogen here, you have 4 oxygen here, you have 2 oxygen here, plus you have another 2 oxygen here on the product side. So the equation is balanced. Additionally, it gives you the status of methane. It's a natural gas, which is CH4. Oxygen is a gas. I'm sorry, I have to put G here. Carbon dioxide is a gas, and water is also a gas. Now you might consider, how is that water is a gas? Because this is a combustion reaction, and when methane is one of the organic compound, the main component of natural gas. When methane reacts with oxygen, it generates over a temperature of 100 degrees centigrade. So at a temperature of 100 degrees centigrade or above, the status of water is not a liquid. It has to be turned into gas. Okay, it has to be evaporated. So chemical equation doesn't tell you just balancing equation, but it should also give you some ideas about the status of substance, what variables are needed, whether heat or pressure or some other stuff are needed. It will also give you an indication. The physical status of the reactants and the products should also be abbreviated. If it is gas, you put G. If it is L, you put if it is liquid, you put L. If it is solid, you put S. If it is aqueous, you put AQ, like we have it here. A good chemical equation should provide you all this complete information. So the next step is we're going to see the types of chemical reactions. How many different types of chemical reactions we know? I'm going to start with the simplest one, which is called a combination reaction. A combination reaction. I'm going to use letters for combination reaction. A combination reaction means that if you have two elements, you combine element A and B and you get C. So when two elements are combined, you get one product. That's called a combination reaction. So when I have magnesium, a solid, which is an alkaline earth metal, react with oxygen, which is a gas, so it's combined and you get magnesium oxide, which is a solid. Okay, remember that the equation has to be balanced, so I'm going to put 2 here and I'm going to put another 2 here. So this can be a good example of combination reaction. The next combination reaction, let's say it's a common way to prepare ammonia from that is the main component for fertilizer, is by reacting nitrogen gas from the atmosphere with hydrogen gas. It's called the Haber process. We're going to discuss about the Haber process sometime, but I just want you to show you what combination reaction looks like. So when nitrogen gas reacts with hydrogen, you get ammonia. It's a gas too. This is a good example of combination reaction. Combination reaction not necessarily be a reaction between element and element. It can also be a reaction between compounds and compounds. For example, if I have calcium oxide, which is a solid, react with water, which is a liquid, and it gives you one product. Remember, the product should be one. It's calcium hydroxide, which is going to be aqueous. Remember aqueous? Aqueous is if water is a solvent, right? So this is a combination reaction. Then we will have a decomposition reaction. A decomposition reaction. What is a decomposition reaction? It's actually the opposite of combination reaction. So if you have, let's say we have one element or one substance C, and it's decomposed. In most cases, it decomposes by heating. Heat is involved, so triangle sign represents heat. So it breaks out to A and B. Okay, this is a good example of decomposition reaction. It's decomposition. You are decomposing one substance, or you are breaking down one substance into two. We call it decomposition reaction. So let's say that we have potassium chlorate. This potassium chlorate is one of the substances that can be helped or that can be used to prepare a small amount of oxygen for the laboratory demonstration. So I can break up potassium chlorate into potassium chloride and oxygen. Okay, this is a good example of decomposition reaction. So I'm going to put 2 here, I'm going to put another 2 here, maybe I'm going to put 3 here, and the equation has to be balanced. So basically, a decomposition reaction is from one substance, you'll decompose into 2. I can give you another example. For example, I have iron hydroxide, iron 2 hydroxide, which is a solid substance, and if I heat up iron, if heat is applied, it can be changed into iron oxide, iron 2 oxide. That's the technical name is, we have to put Roman numerals, remember, because iron is a transition element, and we get water. Alright, so this is also another example of decomposition reaction. Another example of decomposition reaction. So the next type of reaction is a single replacement reaction. A single replacement reaction. What is this reaction to be? It's a reaction between So a single replacement, I can give you an example. Say for example, if you have A react with BC, where A refers to an element, it can be a single element, okay, and BC is a compound, right? So that gives you AC plus B. It's like an general formula for a single replacement. So I may give you an example. Say for example, if you have zinc is a metal, react with sulfuric acid, which is an aqueous solution. So zinc is more active element than hydrogen. So zinc takes a place of hydrogen, and you will have zinc sulfate plus hydrogen gas. Okay, this is a very good example of single replacement reaction. Another example I may add again would be if you have aluminum is a metal, react with copper sulfate is an aqueous solution, and you get aluminum is more active element than copper. You will have aluminum sulfate, okay, and copper as a single metal. This is another good example of single replacement reaction. Remember, every reactions need to be balanced. So I'm going to put 2 here, for example, and I would put I believe 3 here, and I put another 3 here, plus 3 copper. Okay, maybe if you don't see it, I put 3 here. So the equation is balanced. This is called a single replacement reaction. So if we have a single replacement reaction, I may go with a double replacement reaction. A double replacement reaction. What's a double replacement reaction? Let me just give you a general definition of double replacement reaction. A double replacement reaction is a reaction between 2 compounds. A reaction between 2 compounds, which means that let's say you have AB, the compound, react with CD with another compound, and you will have AC plus BD. Okay. Sometimes a double replacement reaction is also identified as a metathesis reaction. In some literature, you may see metathesis reaction. Okay, you see metathesis reaction. So double replacement is a reaction between 2 compounds, whereas single replacement is a reaction between an element and a compound. That's a difference. I'm going to give you an example of a double replacement reaction. So examples of a double replacement reaction. Say for example, if I have silver nitrate, which is an aqueous solution, react with magnesium chloride. It's another aqueous solution, and you'll have silver chloride, which is a solid, and you get magnesium nitrate, okay, with aqueous. So this is like if you take this as AB, magnesium chloride would be as CD. Okay, you can see that the A goes into C and the D goes into B. It's like changing of partners, changing of ions. So you will have AC and BD. Okay, this is what we call it a metathesis reaction, or in some literature you say double replacement reaction. It both makes sense. Now remember again, all reactions should be balanced. So I'm going to put 2, a coefficient 2, to balance the nitrate ion, and I'm going to put another 2 here. Now to balance a chemical equation, as a tip, when you have a polyatomic ion, please give a prioritize a polyatomic ion. Do the polyatomic ion first. That's very important. So if you notice here, nitrate ion is a polyatomic ion. So I'm not counting nitrogen or oxygen. I'm counting how many nitrates I have here. I have 2 nitrates on the product side, and I'm going to put another 2 here on the reactant side. That way I can balance the equation. So when you see a reaction, and if you like to balance, first start with the polyatomic ion and you can proceed. So that makes things easier. I mean, in nitrates, honestly, there is no nitrogen or there is no oxygen. You can't separate them. This is like one unit. It's like one compartment, okay? So you need to consider as nitrate as one unit, not like nitrogen or oxygen per se. Just consider as one unit. That makes things easier. So don't ask how many nitrogen or how many oxygen, but you should ask how many nitrates you have on the product side and how many nitrates you have on the reactant side. So that makes things much easier for you. I'm going to discuss about ionic equation, net ionic equation. That's also very helpful when we have a metathesis reaction. We always need to see ionic and net ionic equation. But before that, there is one reaction I missed. It is a combustion reaction. Combustion reaction that you need to know. Combustion reaction is a reaction of organic compounds, mostly organic compounds, react with oxygen, and the byproducts are carbon dioxide and water. Okay, so we can do some combustion reaction. Maybe earlier I may give you some reactions. Let me give you an example. Let's say we have C3H8. C3H8, which is a propane. It is an alkene family. Reacts with oxygen, and the product is carbon dioxide and water. So here again, whatever reactions that you're dealing with, you need to balance the equation. So you have 3 carbons, so you're going to put 3 here. You have 8 oxygen, you're going to put 4 here. So you have 3 times to 6 plus 4. You have 10 oxygen on the product side, so you're going to put 5 here. So this is called a combustion reaction. So so far we learned about 5 different types of reactions. 5. What are they? Combination, decomposition, single replacement, double replacement, and combustion reaction. Now I may have to go a little bit more about metathesis reaction, because metathesis reactions will not be it's not a one-way reaction. We have to break metathesis reaction into ionic equation and net ionic equation. I'm going to give you the same example. I may use silver nitrate and magnesium chloride. So when we have let me give you an example of ionic equation and net ionic equation. Ionic equations and net ionic equations. Actually, these kinds of equations originated from metathesis reaction. Let me have a barium chloride, for example. Barium chloride is in aqueous solution. Aqueous means it dissolves in water. React with silver nitrate. Silver nitrate. It's also aqueous solution, and provides you barium nitrate, which is aqueous. Any substance that has nitrate is always hygroscopic. It loves water. It can easily be dissolved with water. Plus silver chloride. Silver chloride is actually a precipitate. It forms a precipitate. So I put S here. If you don't see, let me just put here. I can't write very well here. Okay, silver chloride. I put S here so that you can look at it. Now, if anything is aqueous, they have to be aqueous means they have to be dissolved. They have to be broken down into ions. So you have a barium ion and a chloride ion, and silver nitrate as an aqueous. Oh, before that, I'm sorry, I have to balance the equation. So I have 2 nitrates here. I'm going to put 2 here, and what else I need to balance. So I am going to put another 2 here on silver chloride. That way the equation is balanced. Yes. So silver nitrate, if it is aqueous, has to be decomposed into a silver ion and a nitrate ion. Remember, the 2 always be following, the coefficient 2 always be following, because even though it is ionic equation or net ionic equation, the equation have to be balanced according to the law of conservation of mass. Then we also have here barium ion is aqueous with 2 nitrates, aqueous, plus 2 AgClS. We're not going to break this down because it's not aqueous, it's a solid. So these types of equation is called ionic equation. Remember, it's called ionic equation. Ionic equation. What ionic equation means, that ionic equation comes from metathesis reaction when you turn them, when you write them in terms of ions. Now, one of the things that we need to know here is there is something called spectator ions. Spectator ions. Spectator ions are ions do not play, I'm going to give you my definition, do not play any role in the whole process of the reaction. In the whole process of the reaction. They are spectators, they are just watching the whole process of the reaction. Okay, so what it means by that, that there are ions here, you'll see them on the reactant side, you'll see them on the product side with no change. So these ions will be eliminated. So I have barium ion here, a barium ion here. What else I have? Okay, I have a nitrate ion here and a nitrate ion here. They will be crossed out or cancelled. They don't have any direct role in the process of the reaction. So by removing those spectator ions, we will have a net ionic equation. Okay, what's a net ionic equation? A net ionic equations are the equation where we have specific ions are involved and bring change. So on the reactant side, we have 2Ag plus 1 and 2Cl minus 1, and on the product side we have AgCl solid. So this is called a net ionic equation. This is a net ionic equation. So to understand a net ionic equation, one of the things that you need to know is which of the ions are soluble and which of the compounds are soluble, which of the compounds are insoluble. That actually there is something called a solubility guideline. We're going to discuss about solubility guideline on the next video. So today's video is about different types of chemical reactions. To summarize that, we learned about combination, decomposition, single replacement, double replacement or metathesis. We also discussed about ionic equations and net ionic equations. I hope you liked this video, and I'm going to show you about solubility of guideline on the next video. Please share this video to your colleagues, and please send me your feedback, and your comments will be appreciated. I'll see you on the next video. Thank you very much, and have a great one, everybody. Thank you.